Hey guys, so in this video we are going to mix two things. We're going to mix sodium hydroxide and magnesium sulfate, all right? And we're going to go ahead and see what happens, all right? We're going to try and learn some things through this reaction, okay? So on the board, I'm going to go ahead, I'm going to write our chemical equation. And we're not going to get too caught up into the symbols and things like that, but we'll just write sodium hydroxide, sodium hydroxide. Okay, and we're going to go ahead and we're going to get it to react with, so I'm going to write a plus sign. We're adding it to magnesium, magnesium sulfate. Okay, and we should remember these are the two things that we are getting to react with one another, so these are going to be called our, great, these are going to be called our reactants. All right. So our reactants are going to react with each other. We're going to go ahead and take a look at what they create. So I'm going to grab them real quick. So I have sodium hydroxide and magnesium sulfate. And I'm going to go ahead, pour them in at the same time into this beaker. And one thing I want us to notice is let's make some observations about these two things. They're both clear. That's about the only reaction we can, or the only observation we can really make. But I'm going to go ahead and pour them in together. Okay. And I poured those in. And immediately what I notice, okay, is a white substance was made. And we could not predict that. Okay. That is not something that we could predict because we mixed two clear substances and we made something that's white, which is not, okay, not normal. It's not a physical change. Okay, that would be a chemical change. It's an unexpected color change. So that's chemical. And what we would do here, if we look at this carefully, what I'm noticing is, you guys probably won't be able to see it, but what I'm noticing is it looks like there's some chunks in there. It looks kind of chunky. What we actually made a solid. All right, there's some solid particles in here. So we mixed two liquids together, and we got a solid, which is weird to me. All right, another thing I'm noticing, and it'll become more obvious as we go. It looks like there's a layer of water at the top, and then we have a white substance. So a little teeny tiny layer of water and then a white substance. So let's talk about what's happening here. So we reacted sodium hydroxide with magnesium sulfate, and what we went ahead and created, where's my marker? Same thing as when we did the copper, sulfate, and aluminum. There were a few things that just switched places, a couple elements that, or a couple molecules that switched places. What actually happened, same thing here. Okay, we made sodium sulfate, and we can see that right here. I'll underline it. We have sodium here, and we have sulfate here. So those two guys got together. Those two mixed together. And now we're left with just hydroxide and magnesium. So the other thing that was produced, we'll put those together, is magnesium hydroxide. I always run out of room. Magnesium hydroxide. Okay, and these guys over here are going to be our products because they were produced in this chemical reaction. Take a look. I want to see if it looks a little bit better. Oh yeah, I can really see it. I'm going to try and really hope this looks better. Let's see. I'm hoping if I bring it up, I can't really see what you guys are seeing, but I hope you see the chunks in there. Kind of looks like a layer of water at the top. Now I'm going to bring this closer right here. You can definitely see it here now, right? So we have water, and then it looks like we have some like cloudy stuff. That's actually that cloudy white stuff in there. That's the magnesium hydroxide that we're seeing. Okay, and it might look a little bit familiar. Think about what we talked about earlier, a few days ago. Maybe it was yesterday, I don't know. I'm making this video on a Sunday, so I have no idea where we're at yet. do you remember earlier when I talked about something that we had to shake really well because it was not soluble in water and it made a layer of water at the top? Milk of magnesia. Would you look at what milk of magnesia is though? It's magnesium hydroxide. So what we just made, this cloudy white stuff at the bottom, that is milk of magnesia. All right, and let's go ahead and record some things that we automatically know about this. Well, milk of magnesia, because we can see that there's a layer at the top, looks like water, and then we have a chunky layer at the bottom. We know that that chunky layer at the bottom, which was magnesium hydroxide, it must be non-soluble. Non-soluble, right? It's not going to dissolve in water, which is why milk of magnesia says shake it up before you serve it. And I'm going to go ahead and say I'm not going to drink this if I have an upset stomach, though. All right, because there is still, if you look at our chemical reaction, we still have some sodium sulfate in there. That's going to be in there. And then also, not all of the sodium hydroxide reacted with the magnesium sulfate. It wasn't a perfect reaction. Okay, so I'm gonna not take my chances there. All right, but the big thing that I want you guys to get away from this reaction right here, and I'm gonna go ahead, I'm gonna set this up, is something called the law of conservation of mass. And what this base essentially means, and I might even say slash matter. What this essentially means is in a chemical reaction, no matter gets created, no matter gets destroyed. You always end up with the same amount of mass and the same amount of matter. All right, a chemical reaction doesn't just create new stuff. You cannot create matter and you cannot destroy it. You can only change it. All right. So what I'm going to do that exact same reaction, but I'm going to set up my scale, and I'm hoping you guys are able to see it. I'll try and angle my computer here to where, let's see. Hoping you guys can see it. I'm going to reset it. Okay, so I'm setting it to grams. I know it's going to be difficult for you guys to see. And I'm going to go ahead and I'm going to take our two reactants right here, and I'm going to take our final beaker that we're going to be mixing everything in, and I'm going to get a mass of all of that. Okay, and I don't know if you guys can see it clearly, but it says 174, so 174 grams. And what I'm expecting when I mix these two together is for the mass to still be 174 grams. All right, so if the law of conservation of mass is true, this will stay the same. So let's go ahead and do it. Okay, so I'm getting 173 grams. So not really sure where that extra gram went. That's kind of disappointing. All right, but I will say these are pretty cheap scales, so I will rest with that one. All right, I bought these for cheap. But you get the idea, I hope. We don't lose mass through chemical reactions, okay? The mass always stays the same. All right, and we'll do more demonstrations with this later, okay? Proving that mass is never created and mass is never destroyed. In a chemical reaction, you'll always end up with the same amount of matter as before. But yeah, all right, awesome. Thank you guys.